It's interesting looking back how little attention I paid to the state of the industry. It was clearly DAISY Mentor Valid was coming to an end because DAISY was really going down fast at that point in time. And the up-and-comer was SDA that then tried to go public, I think in '87, on literally the day of Black October or whatever it was called, and couldn't, and therefore merged with ECAD, and then became Cadence. And so, and then Cadence acquired Valid a couple of years later. And so the DAISY Mentor Valid really atrophied, and Mentor for a while was very much king of the hill. And they have had their own challenges in the late '80s, I believe. And so there was a change of the guard around that. And so there was definitely this first wave of Calma Applicant CV. They essentially vanished. DAISY Mentor Valid had been there for a number of years, and that changed. And if you look today, Mentor is the only one of the three still alive. Cadence is obviously alive, and we have been the one that not only came in, but then became the leader of the industry.
I accepted the position and became CEO at Mentor Graphics.
Who was CEO before?
Tom Bruguiere. He was one of the three founders, Tom Bruguiere, Dave Moffenbauer, and Jerry Langler. And he was the only one still there because there had been a lot of infighting with all the problems of 8.0. And they had made the decision they were going to hire a new CEO and Tom would move on. And so the attraction of Mentor versus other things is most places wanted to hire a COO because the founder and CEO didn't want to work so hard anymore and they needed someone to run the company. Right. Mentor was actually hiring a CEO, and while the company was clearly troubled, it did have that advantage.
Too, so SDA Systems was new, pipsqueak. I get, let's say it was started in '82. I joined at the end of 1984, and I remember shortly after I joined, I went to a trade show. It might have been DAC. I don't remember which one it was, because I was completely new. None of it meant anything to me. It was just like, wow, it's a whole new world for me. And I remember going. I got the chance. I had a job I was supposed to do, but I got the chance to go and spend a few hours just walking the trade show floor. And so for me, this was literally really my first introduction to the industry at large, other than I'd read stuff in papers about some of the other companies. Like at the time, the biggest, brightest company was clearly DAISY Systems, right? That was the big guy. And up-and-comer Mentor Graphics, and an interesting one on the side, Valid Logic. I mean, these were the names, the comers, the three horsemen, the new hot guys.
The schematic level served engineers to a certain level, but it was clear that Moore's Law was outpacing the design tools that were available, not just from DAISY, but also from Mentor Logic and Valid Logic and Mentor Graphics. So the race was on for where was the next level of abstraction for the design engineer. And increasingly, the research literature focused on a technology called synthesis, which was the ability to compile from a high-level language, similar to a software language, the actual logic and the digital logic, and to optimize that logic for a specific circuit implementation. And the algorithms to enable the concept of compilation was not a new concept. It had been around a long time. But the magic technology of optimization, enabling those compilers to create circuits that were competitive with what an engineer could do manually with his own by hand, brought on a new age of design automation. And it showed up in the literature. I read about it in a number of places and started to explore it as a venture capitalist, actually. After leaving DAISY, I spent time on Sand Hill Road exploring what the next generation of design automation was going to be, and went out and between the various conferences and reading the literature and going to interview various engineers in different places, started to focus on synthesis as the next major breakthrough in design automation. In fact, I approached an engineer who you know well, Kurt Koitzer at Bell Labs. I flew out to Bell Labs, met with Kurt, and tried to convince Kurt to start a company with me to go after synthesis. He thought it was a great technology. He was very much in the middle of it, but he wasn't prepared. He didn't think you could make a company out of synthesis. But he did point me to some friends of his, some colleagues of his that were trying to do that same thing, which were Art DeGius and his team that were spinning out of General Electric. And Art and his team, one of the conditions of getting financed was that they be prepared to bring in some commercial expertise and the CEO to lead the company. And so after meeting Art and Dave Gregory and the other co-founders of what became Synopsys, it became clear that they had the experience and the vision of what to do, and I brought my own experiences to the table, and so that's how we got Synopsys off the ground.
We would run a chip, and we would count stages, so that was our timing model. And then we would run static timing analysis, and usually if we were off by a little bit, we would go back and change the assertions on the asserted arrival times and required departure times, rerun synthesis. So in the beginning, maybe 2 iterations, maybe 3. 2 iterations would probably be enough to converge, and that was fine. What happened was that as we started doing CMOS, the wire length became more significant, and so we would find that it wasn't converging after 2 iterations. And then this very smart guy, still one of the smartest people, David Hathaway, came up with incremental timing analysis. So instead of doing that, why can't I do timing analysis off of the same graph that we're doing the synthesis on? And in addition, when I make a change to a circuit, I don't have to recalculate the timing. I'll just figure out what changed, what's the new timing number. And so that allowed us to do an experiment. We could say, we think it's better to put these 2 gates in instead of this one. Try it, timing, oops, not so good. Let's back that out. And that was a major breakthrough.
Being at the Computer Museum, because a museum sort of preaches that if you understand history, you will learn from it, right, instead of repeating it. And in our domain, learning and repeating are in some ways identical. Let me explain. If you look at the history of EDA or the history of modern design, it's somewhat overly simplified. It's building blocks that you connect. What has changed are the building blocks. Now, the very early building blocks were essentially a few rectangles that you connected them, and now here you go, a transistor, wow. And then the building block became a transistor, and you connect those, and wow, here you have a gate. And then you connect some gates, and now you have a flip-flop, and then it became a little macro, a little adder or so. And then the macro became a much larger IP block, building block, maybe a processor core, or now complete USB core. And then on top of that came some embedded software.